So 8.1, Introduction to Radical Expressions. Expressions with radicals or square roots in them. So a square root of a non-negative real number a is a number that when squared is a. So we're going to be taking square roots of non-negative real numbers. The number or the expression or the variable under the radical is called the radicand. You will not be tested on vocabulary. Evaluate. So can you take the square root of 25? It's a perfect square. Yes. If you don't know, you check it. Second squared button, because that's the square root. We'll give you the square root symbol. 25, enter, perfect square. The opposite of the square root of 16 is going to be negative 4. Because the negative's on the outside. So it's going to stay negative, and the square root of 16 is 4. The square root of negative 4, remember we're dealing with non-negative real numbers. So, square root of negative 4, we can't do this, it's not real. We're not going to be doing this. It's not a real number. So use your calculator to approximate the value of an irrational number to the nearest thousandth. So the square root of 10. So thousandths, we've got tenths, hundredths, thousandths. That's 3 decimal places out. That's a 2. The next one's 2, so we're going to stay at 2. 3.162. Square root of 2 to the 3rd decimal place. It's going to stay at 4. And square root of 7. Notice I'm getting out of the square root before I divide by 2. I don't want the whole thing under the square root symbol. And it's going to go up to 3 because that's an 8, 1.323. Simplify the expressions. We're going to be using these rules. If I have something under a square root and I square it, I'm left with just what's under the square root. Or if I have something squared and I square root it, I'm left with just that a. So here, if I'm squaring a square root, I'm left with just what's inside, just like this. Here, same rule, it'll just be 2. Here, if this is going to get rid of this power 2, and I'll be left with 4. This gets rid of that, I'll be left with 5. I'm going to simplify these. 100 is a perfect square, so that will be, the square root of 100 is 10. The square root of an even exponent is half. So x4. So 10x4. So any even exponent is a perfect square. You just cut it in half. So here I'll have square root of 16 is 4. Square root of x squared is x. Y to the 4th is going to be y squared. So 4x y squared. This negative is on the outside, so my answer is going to be negative. Square root of 121 is 11. Don't be afraid to use your calculator. Half of 6 and half of 10. Simplifying radical expressions. Okay, just like fractions, we're going to leave radicals and lowest terms are simplified. The square root of 24 is a decimal number. We don't do decimals. What we're going to do is we're going to pull out only perfect square factors out of 24. So 24 equals 4 times 6 because 4 is a perfect square. So the square root of 4 is 2. So 2 times the square root of 6 is the simplified version. So 2 times the square root of 6 is going to be equal, but it's in simplest form. So again, the only factors, 24 has a lot of different factors. The only factors that matter are perfect square factors because those are the ones we can simplify. What are those? 2 times 2 is 4. So we have 9. Watch me miss one. 16, 25, 36, 49, 64, 81, 100. So here's some perfect square factors. They could be larger, but these should about do it. These are the only numbers that I'm looking if they go into these to simplify. So here, $12 is divisible by 4. It's not divisible by anything larger that's a perfect square. 12 is equal to 4 times 3. The square root of 4 is 2. The 3 stays inside. Now with odd exponents, you will also have a variable left under the radical. So this x to the 5 becomes x to the 4 with one odd one. So half of the even come out. And you're left with 1 under the square root symbol. Same with the y to the 7th. We'll break off that odd one. Half of the y's come out, and 1 is left inside. So 2x squared y cubed is pulled out. 3xy is inside, and that's simplified. Okay, here I am going to divide 72 by these numbers and see which one is the largest one goes into it. 4 goes into it, 9, 16 doesn't. I skipped 25, but it is divisible by 36, so I stop at that is the largest perfect square factor. So 36 times 2, 6 comes out, and the 2 stays in. 40, I know is divisible by 4, and I'll be left with 10, and that's the largest I can go. 2 on the outside times 4 times 10. This is all multiplication here. The square root of 4 is 2. 2 times 2, this is being multiplied, is 4 square root of 10. 10 is as simplified as you can go. Its only factors are 2 and 5. Okay, negative 4 times the square root of 27 is divisible by 9. 9 times 3, square root of 9 is 3. This is multiplication. Negative 12 times the square root of 3. 20 is divisible by 4, and that's the largest one. So under the square root, we're going to have 4 times 5, and this odd exponent I'm going to break off. So x to the 4 plus that fifth one. Square root of 4 is 2. Square root of x to the 4th is x squared. Underneath the square root is still 5x. $75 is divisible by 25, so first I'll simplify this. Times 3 over negative 15. This comes out as 5. And now the 5 and the 15 can be simplified. There's 1 5 here and 3 here. 25 is a perfect square. B to the 6 is a perfect square. Just this one odd a will be left. So I'm going to break off that odd one. 5, half of these, and the a is inside. So 5 times 2, 10a cubed, b cubed, square root a. I can't reduce 1/4, but this is the next rule that I'm going to go back and forth when I have fractions. I'm going to square root them separately, and they're both perfect squares separately. So here, square root them separately. This is simplified. Perfect square of 5. Here, separate x to the 6x, y 2, square root of 4. So the 5 stays. These get square rooted. X cubed y 5x over 2. Same here. It'll be 2, half of the a's, half of the b's, left with just that a over 3.